Section 5.5, Theorems about roots of polynomial equations. Today, students will be able to solve equations using the rational root theorem and also be able to use the conjugate root theorem. The rational root theorem is going to identify the possible rational roots of a polynomial. To make that list of possible rational roots, you are going to take the p-values and divide them by the q-values. So p represents the factors of the constant term, so the term at the end. And then the q is going to be the factors of the leading coefficient. In our first example, we are going to practice listing all the possible rational roots. So we're going to look at 3x cubed plus 7x squared plus 6x minus 8. So negative 8 is our constant term, and 3 is our leading coefficient. So negative 8 represents p, and 3 represents q. So we wrote down factors though. So let's look at the negative 8 and just think of it as 8. What are some numbers that multiply to 8? So I'm going to start with 1 and 8 so you don't forget that one. And then plus or minus 1 and plus or minus 8 could multiply to give me negative 8. And then there is 2 and 4. So just so you know, all the factors will always have plus or minus in front of it because depending on the combination, it either could be the positive or the negative. So 1, 8, 2, and 4 are all the possible factors of 8. So now we're going to look at q. So numbers that multiply to 3 are just 1 and 3. So now when we do our p divided by q, I would start with the first term and divide it by the first term. And then move along in the p's and keep the q value the same, just so that way you don't make a mistake. And then you're going to go back all the way to the beginning and then do it all over again with the second q value, okay? So we're going to take 1 and we're going to divide it by 1, and so it could be plus or minus 1. Okay, then we're going to take we're going to take 8 and we're going to divide it by 1, so it could be plus or minus 8. Okay, now 2 divided by 1. Okay, then 4 divided by 1. Okay, now we're going to go back to the beginning of our list and change our q value. So now we're going to do 1 divided by 3, which is going to be 1/3. And then we're going to do 8 divided by 3, which is going to be 8/3. And then we're going to do 2 divided by 3, and that's going to be 2/3. Okay, and then 4 divided by 3, and that's going to be 4/3. Okay, so 1, 8, 2, 4, 1/3, 8/3, 2/3, 4/3, all of those could be answers to 3x cubed plus 7x squared plus 6x minus 8. Press pause, and I want you to list the possible rational roots for 15x cubed minus 32x squared plus 3x plus 2. Okay, 2, numbers that multiply to 2 are going to be, I'm sorry, I wrote down the wrong letter, our p-values. And then numbers that multiply to 15 are going to be our q-values. Okay, numbers that multiply to 2 are just going to be 1 and 2. Okay, numbers that multiply to 15, 1 and 15. Okay, 2 doesn't go into 15, but 3 and 5 do. And then 4 doesn't, and then we get back to 5 again. Okay, so now we are going to divide them to actually make our list of possible rational roots. So we're going to start with 1, and we're going to divide it by our first q value, which is 1. So 1 divided by 1 is 1. Move on to our second p-value. So 2 divided by 1 is going to give me 2. Now move back to the beginning, and now we're going to change our q value. So now 1 divided by 15 is going to give me 1/15. And then move on to the second p-value. So 2 divided by 15 is going to give me 2/15. Okay, move back to the beginning, and we're going to do 1 divided by 3, and that's going to give me 1/3. And then move on to the 2, and 2 divided by 3 is going to give me 2/3. Okay, then we move back to the beginning, and we do 1 divided by 5. And then move on to the 2, and we do 2 divided by 5. So 1, 2, 1/15, 2/15, 1/3, 2/3, 1/5, or 2/5 are all the possible solutions to 15x cubed minus 32x squared plus 3x plus 2. So in our last two examples, we were practicing just making a list of all the possible solutions, and now we are actually going to find them. So we're going to start the same way. We have to make our list of all the numbers that we could pick from, and then we're actually going to start trying them. So we're looking for numbers that multiply to -6 and also multiply to 2. So start with our p. So numbers that multiply to 6, 1 and 6. Also 2 and 3, and there's no other values that multiply to 6. So now we're going to move on to the q's. This one's easy, numbers that multiply to 2, just 1 and 2. Okay, so our actual list is going to be 1 divided by 1, which is 1, 6 divided by 1, which is 6, 2 divided by 1, which is 2, 3 divided by 1, which is 3. Now go back to the beginning. Now we do 1 divided by 2, which is 1/2, 6 divided by 2, which is 3, and I already have that one written, so I don't have to write that one again. Okay, then 2 divided by 2, which is also 1, and I have that one already written, and then 3 divided by 2, which gives me 3/2. So the possible numbers that could work are 1, 6, 2, 3, 1/2, and 3/2, and remember that's positive and negative. So to begin trying to find the rational roots, it's just going to be trial and error. And I would always start with positive and -1, and I would also use all the whole numbers before I moved on to any fractions. So I'm going to start with +1, and we are going to do synthetic division. We're looking for a remainder of 0. So there's a 2 in front of the x cubed, a 1 in front of the x squared, a -7 in front of the x, and then a -6. Okay, bring down the 2. 1 times 2 is 2. 1 plus 2 is 3. 1 times 3 is 3. -7 plus 3 gives me -4. 1 times -4 is -4, and I get -10. So, since I did not get a remainder of 0, 1 is not a possible root. So don't forget about -1, because just because +1 didn't work doesn't mean -1 can't work. Okay, so now I'm going to try -1, and again I want to state it's just trial and error. Okay, I don't know which ones are going to work, I just have a list of ones that could work. Okay, so I'm going to try -1. So I'm going to redo the synthetic division again, so that gives me 2, 1, -7, -6. Okay, bring down the 2. 2 times -1 is -2. 1 plus -2 gives me -1. -1 times -1 is +1, and -7 plus 1 gives me -6. -1 times -6 is +6, and look, I got a remainder of 0. So one of my possible rational roots is -1. Okay, and now I'm left with 2x squared, because remember it's 1 less than we started with, minus x minus 6. So you could factor this, you could do synthetic division all over again, or you could do the quadratic formula since it's x squared. So I'm going to try to factor this because factoring is always the fastest way. It may not work, again, I don't know, but I'm going to at least try. So we have to take 2 times -6 and we get -12, and it needs to add to -1. So numbers that multiply to -12 that add to -1 are going to be -4 and +3. Okay, so bring down the 2x squared, then write the -4x, then the +3x, and then the -6. And remember, draw the line down the middle of it. So numbers that go into 2x squared and negative 4x are going to be a 2 and an x, which leaves you with x minus 2. Bring down the plus sign. Numbers that go into 3x and minus 6 are going to be 3, and that also leaves you with x minus 2. So this factors to x minus 2 times 2x plus 3. And then we need to solve them, so we set them equal to 0. So I get that x is 2. Subtract 3. Divide by 2. Okay, so I get x is 2, x is negative 3/2. But remember in the beginning, we started with x cubed, so I should have 3 answers here. And remember, the other answer comes from the synthetic division where you got negative 1. So your 3 solutions to this polynomial are 2, negative 3/2, and negative 1.